let me tell something about the so-called high voltage diodes. They are and were used in, of course, cathode ray tube circuits in the very past, but now, also now, you can find these high voltage diodes, for instance, in a laser printer, in the high voltage unit that is necessary there, and you can harvest them anyway. I bought these high voltage diodes in China. Here you see that bunch. This is what they were telling about the properties anyway, but where are they used for? Well, like I told, in CRT circuits, etc, etc. What are the important things to tell? The internal resistance of such a high voltage diode is very high. And when you try to measure that, say with your ohms meter here, this is say the standard ohms meter on one, you cannot measure here, between here, these two electrodes, the cathode and the anode, you cannot measure whether they are letting through the current in ohms terms, and when you reverse the probes of your ohms meter here, you also measure nothing. And when you do that with a normal silicon diode, for instance the 1N4007, you will see that in one direction the current is flowing, and in the other direction, when positive and negative are reversed, there's no current flowing, and you even measure a very high resistance, endless resistance. And if that's not the case, you know that your silicium diode is leaking, and my advice is throw it away. You see such a typical high voltage coil of an old school television set. This is a high voltage coil, that white bulb, and here at the top of that high voltage coil there was such a diode, normally this one. This is a typical high voltage diode connected, and then it served the high voltage unit of your television set. This is, by the way, a ferrite core. This one oscillated on approximately 16 kilohertz. That is the normal resonance frequency. In that case, it gives out its maximum energy. Anyway, there are more videos about that on my YouTube channel, and my camera is flickering, so I have to be very short. This is also a ferrite material. You can wind on such a ferrite rod, a coil, and a primary and a secondary, and use a high voltage diode like it is showed here. Here the primary, say 10, 20, 30 windings, and here say 800 windings or so. Here you connect your oscillator. There are many circuits on my YouTube channel where you can find transistor circuits that do that job. And then you have here your high voltage diode. In the most ideal way, of course, coupled to the resonance frequency of such a high voltage transformer. Like I told, this is made especially for 16 kilohertz. This one, for instance, is also such a transformer. There is a ferrite core inside, and it is made for, say, 800 hertz or 1 kilohertz or so. Anyway, try, test and experiment. This is not the idea that only with this or that your circuit can work. Anyway, so that was more or less all to tell. Thanks for watching. You can connect high voltage diodes in a row. I've done that here. I don't know exactly whether this was a 30 kilovolt diode. By the way, be very careful, because it can also only handle, for instance, such a high voltage in combination with a tiny current. The data sheet tells us 5 milliampere, but in reality it is, for instance, 100 microampere or so. But at say 20 kilovolt, that's quite a lot of energy. Because a watt is a voltage multiplied by current. So that was more or less all to tell. Thanks for watching again. Here is such a circuit that you can use. Want to refer to earlier circuits on my YouTube channel. Of course you can use here a capacitor to charge up that capacitor, and of course that capacitor must be able to handle that very high voltage. You can switch, say, 500 volts caps in a row, then it can handle 2000 volts approximately. You can stay on the safe side. Well, that's also important. Same applies of course to such a circuit, to such a ferrite transformer. Say the standard 1N5408 is also usable in a certain way as a high voltage diode. It can handle 1000 volts. In theory, I always stay on the safe side. But it's very important to tell that this is a normal silicium diode. You can measure it with your ohms meter here. See whether it conducts or not and in which direction. But say the internal resistance of such a normal silicon diode is in fact very low. So it will not always function when you want to use this in a transformer, high voltage transformer circuit. It can work, but this is, say, the more ideal solution when you want to make a real high voltage unit that has to serve, say, a current in the order of a few milliamperes. But this is also useful, and important to tell, you can switch a few of these diodes, normal silicon diodes, in series. So when you have 5 of them in series, in theory that combination can handle 5 times 1000 volts, it's 5000 volts. And also the internal resistance of such a combi of 5 of these in a row will also go up. So that it means that such a combi, 5 in a row, will load the transformer less. And that's the whole idea of such a high voltage diode. The internal resistance is high because it must not damp the frequency here of the oscillating coil. So you can drive that via a MOSFET, a normal transistor, etc, etc. But say when you use here a normal silicon diode, could be that the oscillation stops working because the secondary coil is damped too much. Anyway, that was more or less the key information. Pen over somewhat. Thanks for watching again. This beautiful old school ferrite transformer, the ferrite rod, the normal diodes. They also can handle 1000 volts, in theory 1 ampere, but of course never 1000 volt at 1 ampere. Perhaps 10 milliampere or 5 milliampere at 1000 volts. The Potcore, etc, etc. It's very hot in the Netherlands now.